So, hello friends, good evening. Welcome to Mathematical Buddha. And we are starting a new chapter which is circles. So, this is a chapter which is circle of the book Understanding Mathematics. So, first we will study about some common points about the circle. So, this is likely to be the circle, and if we put a point in the center, in the center of the circle, this point is said to be the radius of the circle. This point is said to be the center of the circle. And any line passing through it is said to be the diameter of the circle. And if we divide it by 2, so we will find that this line of the circle is called the radius of the circle. This line, which is passing, this is the center, this is the center C. So the line passing from the center, the line originating from the center to any point on the circle which is touching the boundary of the circle. So this is known to be radius. And now second point is third point is this line which is drawn from one end of the circle to another end of the circle. This line is said to be chord. And we can say that the diameter of the circle is the longest chord because it starts from one end of the circle and touches the other end, and this is the longest distance covered inside the circle. Now, the third is the which is tangent. Tangent is a point. Tangent is a line in which touches the circle from the from the outer boundary of the circle, and any tangent which is drawn on the circle at the bottom of the circle, one line is made from this emerging, and always this line has an angle of 90 degrees. So there is a line which is tangent. It only touches the outer boundary of the circle. So now these four things are very common in the circles chapter. Now the things which are easy are such that this part, if we erase this diameter and we create a line here, so these are two chords. So one chord is covering less area, this is less area, and this is more area. So this part is known as major sector. This part is known as major sector of the circle, and this part is known as minor sector of the circle. This part is known as the minor sector of the circle. And now, if we talk about a simple circle, the inner area which it covers is known as interior of the circle, and the outer area in which the figure is enclosed, this area. This is known as the outer or exterior of the circle. So now we will study about these points, and there is also a formula which for diameter is equals to, we can denote the diameter as d and radius as r. So diameter is equals to radius, half of the radius, and 2 multiplied by radius is equals to diameter. Diameter and radius are linked with each other. So now we will study about some theorems of circle. So there are some chord properties of a circle. These properties has 3 to 4 theorems. So first we will study theorem 1, in which we have to prove in which we have to prove that the first one consider the circle. This is the center of the circle O. This this is the chord drawn like this, and these are two lines touching the uh, boundary of the circle. These are the two lines touching the boundary of the circle from the center, which are known as radius. Now we have to prove that OF is perpendicular to AB, and it is given to us that OF bisects AB. OF bisects AB. So now we can see that we will first prove the triangles, both the triangles congruent. As OB uh, in triangle AOM and triangle OMB, we can say that OF is equals to OF. This is the common point in the triangle uh, for the proving that both the triangles are congruent or not. So OF is equals to OF. This is common in both the triangles, and OA is equals to OB. And now this AF is equals to MB. This AF is equals to MB as M is the midpoint. Because it is given to us in the question that OF bisects AB. So the meaning of bisect is that dividing this line, this AB line into half. So OF divides AB in half, which means that M is the midpoint of AB, this line AB. So AM is equals to MB. Now we have proven that triangle AOM, triangle AOM is congruent to triangle OMB. Now we can say that angle AMO is equals to angle OMB because by simplicity. So we can say that angle AMO is equals to angle OMB by simplicity. And now as this AB is a straight line, as AB is a straight line, as this AB is a straight line, it means that the the line which is dropping from the above is 90 degrees from both the sides. Because if they are not 90 degrees, then one more line has to be constructed from here only. Then only we can say that these are not of 90 degrees, but there is only one line which is intersecting, which is joining the AB line from the radius from the point center of the circle. So this um, OM is perpendicular. OM is perpendicular to AB. As uh, both the angles are 90 degree, angle O and B is equals to angle AMO, which is 90 degree. So any line dropping from above which has 90 degree angle is this means that this line is the perpendicular. This line is perpendicular of the next line. So now this line, the base line. So we have proven that OM is perpendicular to AB by this theorem. Now we are moving on to the next theorem. So this is the next theorem, theorem 2 of chord properties of the circle. Now we will make a circle. This is the center of the circle, and this is a chord lying on the circle. Now it is given to us that O is the center. O is the center of the circle, and there are 2 points, this O, A, and B. Now these are the 2 points. We will construct this line for making our work easy. Now this it is given that OM is perpendicular to AB. This OM is perpendicular to AB. Actually, this theorem 2 is the converse of the theorem 1 which we have studied previously. So, and we have to prove that AM is equals to MB or no. We have to prove. So, as it is given that OM is perpendicular to AB, so the AMO and OMB, this angle will be 90 degrees. Both the angles will be 90 degrees. So we have to prove congruent both the triangles in order to prove that AM is equals to MB. So in triangle AOM and triangle OMB, the first of all, the common line which is OM is equals to OM. It is common in both the triangles. Next, that angle AMO is equals to angle OMB 90 degree, as it is given that OM is perpendicular to AB. So these both are 90 degree. Now the last thing is that these are the 2 lines. AO is equals to OB. These are the two lines which are passing from the center of the circle to the point, to the boundary of the circle. This is the boundary of the circle. This is the line. So any line which is originating from the center and touching the boundary of the circle, this line is said to be the radius of the circle. And both the lines are doing so, and all the radius are equal to each other. All the radius are equal to each other. It means that any line drawn from the point center to any direction, and if it's touching the boundary, so that line is the radius, and the radius of the circle is equal. Any radius. The radius of the same circle, as they are on the same circle, so they will be equal. OA is equals to AO is equals to OB. Now we have proven that triangle AOM is congruent to triangle OMB by side angle, or we can see that by the RHS, right hypotenuse side. So now we have proven by this theorem, we have proven that both the triangles are equal. So now AM will be equal to MB by CQ/CT. By CQ/CT, both the lines will be equal to each other. Now we are moving on to our next theorem, theorem number 3. So we are moving to the theorem number 3 of the chord properties of a circle, which states that in this we have to prove that the equal chords are equidistant from the center of the circle. Equidistant from center of circle. This is the theorem number 3, that equal chords are equidistant from the center of the circle, in which this is the center. We draw 2 chords which will be of equal length, A, B, C, N, and M, P. Now we can say that, and it is given to us that AB is equals to CN. it is given to us that AB is equals to CM. So now we can say that any line dropping from the center to any chord of the circle is the perpendicular, and it also bisects from the theorem 1 and theorem 2 of the chord property of the circle. So now we can say that OP bisects CM, and now we can say that CP is equals to CM, CP is equals to PN, as P is the midpoint. P is midpoint. CP is equals to PN as P is midpoint, and this OP is also perpendicular to CN, which means that angle OPC is equals to 90 degree and angle OPN is equals to 90 degree. Now in order to find that both of the uh, chords are equidistant from the center of the circle, we will draw two radius which is from the center of the circle to the boundary. Now we can say that OB is equals to ON. First we have to prove that first we have to give this equivalence, give like this only. We have to prove that AB also. So ON bisects AB, as I have previously told that any line any line from the center of the circle to any chord bisects the chord. That line must be coming from the center of the circle. So OM bisects AB, which means that AM is equals to MB and N is midpoint. This we can also like in this case we can also state that OM is perpendicular to AB from theorem 15 from theorem 2. So OM is perpendicular to AB, and we can state that angle OMA is equals to 90 degree, which is also that angle OMB is equals to 90 degree. Now we will prove both the triangles equal in order to find that these chords are equal chords are equidistant from the center of the circle. So in the triangle OBM and ONP, OB is equals to ON, as both the lines are equal because radius of the same circles are equal to each other. And we can say that it is given that AB is equals to CN. So if AB is equals to CN, then half of AB is equals to half of CN, which means this P and M bisects the AB and CN lines. So half of AB, we can take that half of AB is MB and half of CN is PN. So MB is equals to PN. So we can state that MB is equals to PN. And this is given in the question that AB is equals to CN. Now we have proven both two lines that are congruent, that OB is equals to ON and MB is equals to PN. And AM is equals to MB. This is the separate point. We are proving that congruency of the triangles. So now the other line is that we can also prove congruency. Now the third reason is this OMB is equals to 90 degree, which we have previously done, and this OPM angle OPM is equals to 90 degree. Both the angles are equal. Angle OPM is equals to angle OMB, as these are both the perpendiculars. Because of the both perpendiculars, these are equal to each other because of perpendiculars. Now we can say that triangle OMB is congruent to triangle OPM by arches congruence rule. So now we can state that OM is equals to OP by simplicity corresponding parts of congruent triangle. So we have proven that the theorem. We have proven that equal chords are equidistant from center of the circle by this, that OM is equals to OP by congruent, by proving that both the triangles are congruent, and this is by the corresponding parts of the congruent triangle. So this we are moving on to the theorem number 4 of the chord properties of the circle, which states that the chords which are equidistant from the circle, from the center of the circle, the chords which are equidistant from the center of the circle are are equal to each other. So we can say that by proving the triangles. So now we have to prove that the chords which are equidistant from the center of the circle are equal. So we have to prove that AB is equals to CA, and it is given. It is given to us. It is given to us that both the chords are equidistant from the circle, which is OP is equals to OM. So we can draw in the from the center of the circle to the line to any chord of the circle. This means that that line bisects the chord. So OM bisects CM, which means that CM is equals to CM as M is the midpoint. CM is equals to CM and N is the midpoint, and OP bisects AM. AB. OP bisects AB as and AP is equals to AB as midpoint is P. So these are the this states that AB is equals to AB as the midpoint is the P, because any chord from the center bisects any chord, any line from the center bisects the chord into half. So now we can state that AO is equals to CO, and these are radius of the same circle. Equals to CO, and these are the radius of the same circle, and this OP is equals to OM, and angle APO is equals to angle OCM, because any chord, any line dropping from originating from the center of the circle to any chord bisects the chord, and it also says that it also proves that the angles around it are of 90 degrees. By theorem 1 and 2 we can take that. So APU is equals to angle CMO as OP is perpendicular to AB and OM is perpendicular to CM. Perpendicular means this would be that the angles are 90 degrees. So these both the angles are equal. So we can state that by the by we prove the triangle is congruent, which is triangle APO is congruent to triangle CMO by RHS congruency rule. So we have proven. Now we have to prove that AB is equals to CN. We have to prove that AB is equals to CN. Now, and we have proven that both the triangles are common to each other. AB is equals to CM. This is AB and this is CM. AB is equals to CM by simplicity. Uh, AB is equals to CM by simplicity, and if AB, as it is given that this P is the midpoint, so AB is equals to half of AB, and AB and CM. It will not be AB and CM is equals to half of CM. Now we can substitute these values and we can write that half of AB is equals to half of CM. As AB and CM are equal to each other, so these both the values will also be equal to each other. Now if we multiply this by 2, or we can easily, if this is the, or we can easily say that this, if we remove this half and not multiply it by 2, if we remove this half, we can say that AB is equals to CM, because this AB is half and CM is half, and if both are squared, so then they will be of equal length. So AB square is AB and CM square is CM. So AB is equals to CM by this method only. Now we are moving to some questions. So this is the first question of the circles chapter, which is calculate the length of a chord which is at a distance of 12 cm from the center of the circle of radius 13 cm. So now we will draw the diagram. This, and we will first, this line is of 12 cm. This is O, this is A, this will be M, this will be B, and it is said that the radius is 13 cm and the distance of the chord from the center is 12 cm. So OM is equals to 12 cm. OM is equals to 12 cm and O, and the radius is 13 cm. So now make a big diagram. A, M, B. This is the radius O. Now the given to the, these things are given in the question. These things are given in the question that radius is 13 cm and this OM line is of 12 cm. Now we have to prove that we have to calculate the length of the chord. This length of the chord we have to calculate. So by the theorem 2, it states that any line dropping from the center bisects the line which is AB. So this line OM bisects the line AB, this line. So AM is equals to MB, as M is midpoint. Then AM is equals to MB. So now by Pythagoras theorem we will prove. So OA is equals to 13 cm. It is written there by Pythagoras theorem. OA square, which is 13 square is equals to OM square, which is 12 square plus AM square By this, we will find the length of the chord. So 13 square is 169 and 12 square is 144 plus am square. This will be square. Now this 144 will be set here for finding the value. So it will become 169 minus 144 is 25, which will be am square. Now both the values will get rooted and we will get the value of am as 5. So as we have got the value of am as 5, this is written that am is equals to mb. So this line AB is equals to 2 into AM or 2 into MB. So we can say that as we have found the value of AM, 2 into 5, which is 10 centimeter. So we have found the length of the chord and the answer of this question will be 10 centimeter. That AB is equals to 10 centimeter, this chord. Now we are going to the next question. So this is the question number 2 which is given to us. A chord of length 48 cm is drawn in a circle of radius 25 cm. Calculated distance from the center of the circle. So now this is the circle and this is a chord of 48 cm. This is the 48 cm. This is AB and this is the center of the circle and the radius will be 25 cm. The radius is 25 cm. Now we can say that we have to find the distance from the center of the circle. So we have to find this. This is the distance from the center of the circle. So by Pythagoras theorem we will find it in a triangle. In triangle, this will be point M. This point is point M. So triangle OMB, OB is equals to 25 centimeter. Given that radius. This is the radius, that the OB line is the radius because it is originating from the center and touching the boundary. So OB is the radius 25 centimeter and this AB is equals to 48 centimeter. So as this line is dropping from the center to this chord, so this means by the theorem number 2, OM bisects AB. So it means that AB is equals to half of AB is equals to AM, or we can say that half of AB is equals to MB. Both the conditions will be true. So this will be MB. AB divided by 2 is equals to MB because OM bisects AB. This AB is 48 centimeter. So MB will be half of 48, which will be 24. Which is the length of MB. So now we have the length of OB, we have the length of MB. We will find by Pythagoras theorem what is the length of OB. So by Pythagoras theorem, OB square is equals to OM square plus MB square. So OB square has the value of 25 square, which is, and OM is OM, we have to find that OM, and MB square, MB is 24. 24 will be whole square. Now 25 square is 625 and OM square plus 24 square is 576. So this 576 will be transferred here. It will for further calculation and it will become this. So 625 minus 576 is 49, which is OM square. Now 49 will be rooted. So it will become 7, which will be the value of OM. So we have found the distance from OM. Distance of the chord, which is 7 centimeters. And this is the answer. So thank you for watching my video, and please like and subscribe to our channel and press the bell icon for watching more exciting videos in the channel.